Once again on integration. This chapter is quite long, and in the meantime is also super interesting as well. So let's begin. We have the integral of the exponential function e to the power nx dx equal to the exponential function e to the power nx divided by n plus the constant c. Alright, let's take few examples. We got the integral of e to the power 2x dx equal to, however, we know that the value of n here is nothing but 2, meaning that we can write it in this format, and we know that since the value of n is 2, we're going to replace n by 2. Wherever there is n will be 2. So the answer to this will be e to the power 2x divided by the value of n is 2 plus the constant c. Let's take another example for the sake of practice. We have the integral of exponential function e to the power x, and as you can see here, we have the value of n, which is 1, meaning that this can also be written as e to the power x divided by 1 plus the constant c. Let's keep moving. We got kinds of exponential functions. Let's look at this one. We have int, and this type of exponential function a to the power x dx equal to a to the power x divided by f prime of x ln a plus the constant c. Let's have examples under this. We got int of 5 to the power x dx equal to 5 to the power x divided by, however, the derivative of x here, as you can see, f prime x is the derivative of x. In our case, we have 5 to the power x, and the derivative of x will give us 1, meaning that we're gonna have 1 times ln, and in place of a, as you can see, a here is a to the power x. However, here we got 5 to the power x, meaning that the value of a is 5. Then we have 5 plus the constant c. Here, let's have another example. Okay, we have the integral of the exponential function 2 to the power x. However, we can write it in this form. If we write it in this format, here we will place 2, since the value of a is 2, and we have to derivate the exponent x, meaning that even here we still have the exponent x, and the derivative of x is nothing but 1. Okay, we're gonna have 2 to the power x all divided by the derivative the derivative of x, and the derivative of x will give us 1 times ln of this time around. In place of a we got 2, then we will substitute a by 2 plus the constant c. Guys, if you still recall, under integration we got this kind of formula where x to the power n is this one, and we added we add 1 to the exponent n, and same applies to the denominator. We have n plus 1, which is the exponents, this one, x to the power n plus 1 plus the constant c. Okay, let's have this example. Int of 1 divided by x dx equal to we have the integral of 1 divided by x. 1 divided by x is nothing but the inverse of x, which can also be written as x to the power -1 plus 1, all divided by the exponents -1 plus 1 plus the constant c. Okay guys, the reason why this is not equal to this is on the denominator, as you can see, -1 plus 1 will add up to 0, and in maths we don't permit such, because this will give us undefined. Then the correct way of doing this is the integral of 1 divided by x dx equal to, then we gonna write it as ln x plus the constant c. Okay guys, why do we have to write it in this way? Let's derivate this one so that we check whether what we did is correct or not. Then the derivative of this one, if we did the correct manipulations, the derivative of this one will gonna give us the original equation as 1 over x. Okay, let y equal to, this time around we have ln x plus c, then ln x plus the constant c. However, to derivate the derivative of this one, we know that it's gonna give us 1 over x, since we know that the derivative of ln x is x prime divided by x, and x prime is 1, since the derivative of x will give us 1. Okay, we're gonna have dy divided by dx equal to, the derivative of this one will gonna give us 1 over x, and the derivative of a constant will disappear, since the derivative of c will give us 0. then therefore we're gonna conclude that this is the only solution to this.